I'm very glad to be here because 5 years ago with Franck Simon, we interact together for teaching the layer 1 support with the other scale when I used to work for SDN Networks. And I'm here as a person from TOUIX, the Toulouse Internet Exchange in Toulouse. And I'm doing a PhD in the last CNRS in Toulouse related to SDN for Internet Exchange and some other aspect. I'm going to present the Toulouse Internet Exchange briefly. SDN, most of you know what it is, but I just want to give some words about it. And EXP Fabric in general, and the 2.6 for SDN was actually in production of the Toulouse Internet Exchange, and the applications we developed as a 2.6 manager, and it's just the beginning. Then we're going to talk about different things happening. Toulouse is here. Then if you look France, we're not connected the same way as in Paris, or even Lyon, or some other city, even in Brittany. And this is obviously kind of problem if you want to grow, but you can do a lot of things around your network differently than others, because it's a big city of engineers, and there is a lot of people doing networking as well in that city. Then the Toulouse Internet Exchange has been funded 10 years ago by one of the founders here is Hugues Brunel from Full Save. And there is 4 POPs, 4 point of presence around Toulouse. Then we can see on the map the fibers around Toulouse connecting the different locations. There's actually 10 members, and there's no, it's not a lot after 10 years. Then the SDN. I think today, even in France X, the equipment used is the equipment are closed. Closed mean that the application running could be running on top of Junos, included in Junos or Juniper or Cisco or whatever vendor today. Most are running on operating system with embedded and closed as well. You don't know the source being used there. And you have a specialized packet forwarding hardware. It's mostly Broadcom today, or some vendors for big chassis are doing their own ASICs, their own hardware equipment, hardware device to be able to forward the packet. Then this is what we had in terms of computers in the 70s and even in the beginning of the 80s. IBM was kind of Cisco was today. And the approach is to open what has been done at the beginning of the 80s is to open the interfaces. If you get Broadcom, if you get an ASIC, if you get things you can program, and you have a kind of standard, you're able to program you simple packet forwarding hardware, then you can have an abstraction layer and introduce the concept of the network operating system. And most of you, I hope, just heard about OpenFlow. Then here we're talking about OpenFlow that we see here. And this very different approach. Obviously, some people think it's, oh yeah, it's going to be centralized and everything. But it's already, we're talking about administration centralizations. And this is someone who is just managing the BGP AS is the same approach, but it gives so much benefit in terms of maintenances. And one of the big network running today is the Google network, is running in OpenFlow mode for more than 2 years already. When we talk about equipment today, then it's not only closed, they do a lot of things. They are able to do a lot of different things. And you have to turn off some of the features. They're already turned on at the beginning by default. Then with OpenFlow, it's different. And with OpenFlow, you have a switch, you turn on, it does not do anything. It just do nothing. You have to to give some open flow rules to start to do something. And when you give the right rules, then you can have a beginning of something who's really specialized fabric for the Internet Exchange, for example. Then today, Internet Exchange fabric, they have some limitation. They have a big broadcast domain. They could be spanning tree VPLS as the best solutions today that TOUIX, DKIX or AMSIX are using today. But it's a lot of engineering to maintain such fabric, and it's specialized for some other things. It's multi-tool things for not specially designed for EXP. Then you can have loop. Then you can have broadcast storm. And you have to teach what you need to be filtered. And it's actually, those big chassis are designed for many different purposes. I just want to remember, but it's been fixed, as Frank mentioned early in this morning. But that was one of the issues, and they have to turn off some other protocol was going into the fabric, and it has to be configured differently. And it was an outage. Then I'm going to talk about what we've done in Toulouse, and everything is based on the research I've done in the last year and a half. Then, as I mentioned before, Toulouse is small, and we had that possibility, and the great team in Toulouse of the different members allowing us to, based on the design, to migrate in production. But this design is based on we call umbrella fabric, and as what we do is kind of pretty simple. Then our whole HARP packet, HARP requests are in broadcast. As we know the destination, because we know where the member target address is, because we know where the router of the target is, then we can rewrite with an open flow rule in unicast that broadcast. Then it starts with that. And then we actually just teach the open flow switch just to do that simple things, and the rest will be dropped. And we open the pseudo wire, just because only the packets who need to be received by the destination is received. And we also a segment routing approach, because what we have is the label switching. We encode in a special way the MAC address destination from the H switch of the fabric. Then is actually one by one up encoded directly in the MAC address. Then the path is deterministic, and is entirely proactive. It means you can lose the control channel, you can lose the open flow controller, and the fabric will still running. It doesn't need to be connected all the time to the controller. Then you get much more monitoring capacity. That's a good point, because you can teach the ASIC to count whatever you want, and it will consume some of your rules of the open flow table, but it's much better precisions. And the open flow today get us also redundancy capacity on the links, and for the umbrella fabric, you can even use the whole big chassis you had, or the legacy one with Marc learning, using policy-based reading in mode switching. You just have to check the first bytes of the MAC address destination. Everything's going to be in a research paper, which is actually submitted to different conferences. Then you will come back, if you want, to the Toulouse Internet Exchange, or another website I will mention later on, to get much more details and everything's an evaluation we made on the fabric. That's what we had before. We had 4 POPs. They're connected that way. We had kind of spanning tree, but they were not really stabilized, and it was running fine because we had direct fibers with no other equipments in between, no other active equipments. These are Cisco switches. They're still there. and are gonna see how we still use them actually. We choose a Pica8 switches, simple ones, just very inexpensive, and then is using open vSwitch with a very robust open flow agent, and then we can use that open vSwitch as your other abstraction of any other switches. We not vendor lock. We can use different type of vendor below the open flow interface. As we need 1.3 open flow version for some monitoring functions I'm gonna talk later. And that small is switch. It just depends the way you configure, but is 4,000 open flow rules capacity. Fabrics is enough. If you use just for wadding, even 2,000 is enough to run AM6 today for a couple of years. But if you want to have monitoring, you need much more open flow rules using the umbrella fabric approach. Then we install this. Then we place on top of the existing Cisco switches, and we were to the different locations. We had only 3 of them because one of the POPs had only 1 member. Then we use that fiber to connect directly the layer 2 links to the one of the other POP, because it was no other way, no growing numbers, no one gonna be connected to the hotel telecom. Then what we've done is just to get that running, and we still see the Cisco, because we need to get the control channel connected. We need to be able to get an open flow connections, just to be able to just add, remove or modify MAC addresses of the router connected. It's just the only things you do. Then the monitoring table, we have a second open flow table who just count the packets we want in full mesh. We can connect all the different members, and we know precisely who is talking to who per precise byte. And if the controller who is actually connected in Cogent POP is rebooting, had a power outage, whatever, the fabric still run. We just lose the monitoring. We placed those switches in production in May. We didn't have any outage, no problem of broadcast whatsoever, because everyone is just receiving unicast. And we really increased the security for different aspects. Then the TOUIX SDN TOUIX manager is something we're going to place in production. Then the person we saw previously on the picture, Rémi, was doing his internship to work and help us to implement those switches in productions and to code and to program that TOUIX manager. Then managing the members means just you get an interface where the member can say, I want to be connected there, or I need to change my MAC address. If you are a new one, you have to give you financial details, where you base and all information, legal information, to be connected to the fabric, and you provide where you want to be connected and which MAC addresses you're using. Then we give them an IP on the EXP subnet, public subnet, and all the details to be connected physically. Then we just have to push a button and just generate the different flow. If it's changed or removed, it's the same thing. It just generates automatically the different flow rules to be pushed to the fabric itself. We also configure automatically the root server with BRUYERE. And we have a separated graphic visualization module. We just, the second table we use was just, if it's lost and we don't remove, we just lose the visibility on the fabric, but it's still running. And this is actually kind of the beginning. Rémi was so pleased to do his internship in the last NRS for Toulouse Internet Exchange. he's gonna initiate his PhD as well to continue the work. And a lot of members are just actively involved because they are paying for this. They want to have something in running for innovation differently in Toulouse. And also some different people want, especially the president, Claude Combe, were thinking of marketplace. Then get something automatic like this in the metropolitan area. Then the different data centers and operators, they can propose different things, and the interconnections could be done differently. There's different aspect of it. What I have not mentioned actually, just is we get two other internet exchange connected to that fabric. One is the TOUIX. That is, we had to maintain it on the Cisco. We had a special VLAN on the Cisco because they have different MAC addresses. Then, if the MAC addresses are known by us, we can program the fabrics to include those MAC addresses and forward them. And we get Linux. Linux is interconnected directly by routing through the root server, their root server. Then Linux is sending the BGP prefixes to her root server. And we just send to one MAC address and is directly connected to there. Then is one other aspect of the project, research project we have for that PhD, coming PhD of Rémi. In parallel, more than a year ago, 1 year and a half ago, we initiated to propose to the European Commissions to work for 3 years. Then we get funded, we get a grant to be able to work on the SDN XP. And with the Queen Mary London University, TOUIX was one of the major internet exchange in Europe. UCL was in Louvain, IBM Zurich, and University of Cambridge, and obviously the last CNRS. If you want to check it out, just get onto URL, and there's different deliverable, and gonna be public soon after the review of the commission. Just for the first half year we were working on, there's a lot of information there. Then, if you have questions, I'm open.
Hello, Raphaël Monnier from Mediactive. So I have a question. So everything is perfect and beautiful and sexy on the paper, but are we able to stress test how to scale? Because we know that TOUIX it's small today. How you can see the future that can under traffic, Storm Broadcast, or even Flaplink?
Yeah, Storm Broadcast doesn't exist anymore because it's just unicast. We rewrite the things in unicast. There's just no MAC addresses with any encode of broadcast or whatever.
Yeah, but if you receive a huge amount of traffic, my question is how the process can handle it?
Like any other switch or any other situation. Just if a lot of traffic coming from one port to another is a matter of design, you just need to provision the links to be able to be non-blocking fabric. And it's just a design problem. It's no problem of the protocols involved here. Then I had an Ixia, my own Ixia. Then obviously all the testing there are just pushing 10 gigs of traffic, all the power had, and it's in some way, and I would say it's simple. Just if you look the rules, because you just teach what you want to the fabric, is different, very different aspect.
So the issue is not just the hardware, it's the software. That when at the beginning of the issue with TOUIX, it was not a hardware issue, it's always software issue.
Okay.
So my question is mostly not about the ASICs and silicons.
Yeah.
It's how you
here is no software. As you see, we're just talking about the fabric itself. The manager just do simple things. The MAC address of the router connected. It just add it to the fabric. It doesn't do anything else. The other things is another table, just get full match table, just to see who is talking to who, just counting the packet, nothing else. And just the software on top of it is very, very simple. We just get something very, very simple on the fabric itself. For redundancy links, we use OpenFlow group fast failover. And if you do not have the fee going down, then you cannot detect sometimes some situation because you have optical equipment in between who maintain the fee, and you cannot detect the link going down because it's dropping at the end of the fiber or middle of the fiber between two pops, for example. Yeah, you can activate some other from Pica8, for example, LLDP or asking the controller to inject some other traffic just to ensure that the fabric is running to different pops. But it's already mechanism into the broker magic to be able to detect such things point to point when it's not the fee going down. And based on it, just very, we want to keep the fabric as it is, very simple. And the software on top of it, just very close to EXP Manager, with a lot of different tools developed, but we wanted to not use EXP Manager, we wanted to develop BRUYERE, who aspect of just managing different aspects of, not ready to the fabric. I'm talking just changing MAC address, but the rest, the billing, checking what was going on, changing the information of the members, and that's it.
Do you have any information about large-scale network using it for now? Because it's...
Oh, well, as I say, we're the first one. The very first SDN fabric running was a layer 3. It was a cardigan in New Zealand. GCSB was the NSA in New Zealand. Just put the local TIXA in October. And TIXA forced every operators to inform 20 days in advance of any modification. Because cardigan was in SDN, changing in milliseconds, the way that the traffic getting through the cardigan fabrics, they had to turn it off. They were the first one. They were running layer 3. There was a Google guy who was in operation in US before. We went there, and he's called George Bailey. But they had to turn it off. Then we're now the very unique SDN EXP platform in production. There's no other ones today. It's still research, we can say, but it's in productions. And there's the work of saying just the beginning.
Are you able to share the stress test scenario you made?
Yeah, if you want. Sure.
Thank you, Marc. And thanks for presenting something different that brings a new approach to internet exchange points.
Now, in 2008, we tried to reach out to the exchange points that we knew existed. There were 17 of them, and only 12 responded. And we tried.
After having installed the Juniper boxes, we remove all the edge equipment to install the Brocade we have in the core. So we remove more than 7 boxes.